This is EL6303 homework 6, problem 1. In this problem, the statement gives us the joint density function of the random variables x and y, like this. And this is a range of x and y. Yeah. First, they need us to decide the value of a from the property of the density function. We will know that x and y, they do integral from negative infinity to infinity should be 1. And from this we know that a is 4. And the second problem, they need us to decide whether x and y are uncorrelated. So we can get the density function of x it's a 0.5. That's a constant. So we can know that Ex, I mean that the expectation of x is 0, but the expectation of x multiplied with y is 1/9. So it is obvious that expectation of x multiplied with y doesn't equal with expectation of x multiplied with the expectation of y. So they are not uncorrelated. So of course they are not independent. In first problem, they need us to decide the joint density function of x squared and y squared. So we get z and w like this. So this is a Jacobian Jacobian matrix of x and y. Yeah, and z equals x squared, y equals y squared. So we can have 4 pairs of roots, but the absolute value of Jacobian matrix of x and y will all be this value. So we can get this. Well, when z is smaller than 0 or bigger than 1, and w smaller than 0 or bigger than 1, the joint density function of z and w will be 0. So we can get that the joint density function of z and w will like this. And if we do integral from minus infinity to infinity, we can get that fz is this and fw is this. So it is obvious that the joint function is the can get from the multiply of the product of fz and fw. So they are independent. This is a result of fourth question. That's all. Thank you. This is for homework 6, problem 1.